Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're going to talk about intent-driven design. And so this is a new functionality or a new experience, as it's being called, in Fusion. Right now it's preview, but it's going to be default in the near future. And so it's important that we understand what it is, how it works, and what to do going forward. We do have an assembly course on our website, learneverythingaboutdesign.com. If you have purchased that, we will be updating it and you'll get an email when there's new content added to it. If you haven't purchased it and you're interested, if you buy it now, it's only $10. If you buy it now, then you will get notified when it's updated and you'll get access to the new content as well. So in this video, I'm going to focus on how we turn this on. I'll give some basic examples and then I'll dive a bit deeper and so we can understand how this stuff works if you want to stick around. And so the first thing that we want to do is go to our user preferences, go to preview features, and toggle on intent-driven design. So intent-driven design, there's a learn more option. It'll take you to a website where you can kind of read about what's going on. But this is basically going to give us the option to determine whether or not we're creating a part, an assembly, or a hybrid design. Hybrid is how Fusion works now. There's not going to be much change to that functionality, but I will talk about sort of how to go between all of them. Another sort of general note is there's a default design type you can change, but all this really does is highlight which option from the menu. It doesn't actually automatically jump into it. Quick side note, there is a Fusion Classic theme. I did mention in a post recently that I didn't really like some of the changes that were made to the Fusion UI. I tend to get a bit set in my ways. I don't like it when things change when they really don't need to. But keep in mind that Fusion Classic does go back to like the old color scheme for things like the surface tools. It does change the folders back and the sort of expanders back. However, it doesn't work with everything. What I mean by that is some of the new stuff that we're going to talk about with intent-driven design. The menus are new. Everything is rescaled, it's rounded, and things like that. And it just doesn't update with some of the newer stuff. So Fusion Classic is a nice option, but unfortunately, I'm just going to have to kind of deal with the change and roll with the new stuff. All right. So if you're wondering what this is, if you've come from SolidWorks or Inventor or NX or pretty much any other CAD system, you're used to selecting part or assembly when you got started. That's been around. That's how parametric CAD systems have been. In the early days, there were actually a lot more direct modeling, but probably since at least the 90s, if not, maybe earlier, this was the default workflow for pretty much every CAD system. Fusion shook that up when it was released in its current iteration around 2015. Before that, there was something called Inventor Fusion, which was web-based. This Fusion is different, but ever since it started, it was a hybrid design, which meant you could go in, you start modeling bodies, components, you could convert, you could move things around. It didn't really matter. Now, obviously, there were kind of right and wrong ways to do things. So there were certain rules in place where if you wanted to build an assembly, you should start by creating components. But the hybrid approach is actually one of the reasons that drove me to Fusion. That flexibility and the ability to just kind of get in and model is something that really appealed to me. I don't love the idea of having to go to a part or assembly kind of structure, but it does have its place. I mean, I've been using CAD since the 90s. I understand that my way of modeling is not the way that everybody models. So I understand that having metadata associated with a part or an assembly makes sense in a lot of cases. So if you are working with other users, collaborating on projects, building large assemblies like over 500 components, or generally just working in a more production environment, the part and assembly structure is kind of the standard. So as you work in PDM systems, for example, where you check in or check out designs, having the ability to say that this design is a single part is something that's important. And so Fusion was a little tricky in that sense because you really could have a bunch of internal components, some external components, some bodies, And if a body wasn't a component, it doesn't really show up on a bill of materials, or it doesn't get checked in the same way to a PDM system. And so, as bigger industries use Fusion, as bigger teams use Fusion or more collaboration, this structure does make sense as an option. I hope that hybrid stays around because I think it's really powerful, and probably the vast majority of Fusion users can still really benefit from that hybrid approach. The good news is right now we still have the ability to sort of convert between all of them and decide on the fly, but there are restrictions. And again, I'll talk about that a little bit later in the video. So as you're getting started, the first thing that you want to understand is have a picture of your design. Are you creating a part? And typically a part that was external was meant to be used in multiple assemblies. In this case, that's not really sort of the default definition. What this means is you're designing a single body part, a single body component in sort of Fusion speak, and that's going to get inserted into assembly. Now, it doesn't have to be. I'll show you an example of multiple bodies in a single part, but that is the sort of default rule that we want to follow. The assembly design, this is typically where you're going to be bringing in external parts and putting them together how they would be assembled in reality. And then the hybrid design is how we use Fusion today. Again, just some minor exceptions, some nuanced differences I'll talk about, but essentially, if you've been using Fusion, that is how you continue to use Fusion the way you use it now, by hybrid. All right. So I keep slouching in my chair today. Let's sit up a little bit better. All right. So when we create these designs, and I'll start by creating a basic part. Note that you can pick sheet metal or a basic part. When you create this, you'll notice the absence of assembly tools. There's no assemble menu anymore. And really in an assembly now, what we have is all the assembly tools on a tab. And so you just have access to the part tools. And one other piece of information is in the document settings, it's declared a part design. This means that we can create a bunch of solid bodies, but we can't convert them to components in here. So if I I'll just use this as an example. If I extrude this up, and I'll bring the sketch back, and I'll extrude this one up as a new body, we don't have a new component option, and there is no option to convert these to components. So they are bodies we can create, we can add, we can remove, we can combine them together, we can do all that stuff, but we can't convert them to components because at the core, a part design is only a component at the very top level, which is different than how it works now because we can convert and remove and delete components however we want. The other thing that's new is we've got this assemble option to add to assembly. This isn't saved, so I'll just go ahead and I'll save it as untitled. Bad practice. Don't do what I do as I say, not as I do. All right, and so we can add it to a new assembly or an existing assembly. And so inside of here, this component has two bodies in it. And again, we can't right click and convert them. That's not how it works in this new assembly environment. And so at the core of this, what I want you to understand is when you're creating a part, really think about it as a single body inside of a top level component. A component is going to contain sketches, it's going to contain construction geometry, it'll contain decals, it can have canvases, things like that. But at the core of it, you really want it to be a single body inside of that single component. The assembly of components is going to be all external. There is no internal component that's added to the assembly type. And again, under document settings, we've got assembly design. And so what we want to think about here is we need to be very clear about when we put stuff together. And what I mean by that is if you're used to the hybrid approach where you can kind of make basic representations of components and do things like add fillets to edges and be okay, that's not really how it works anymore. And so what we need to do, so for example, with this collar, if it's external, we need to use edit in place. And I'll dive deeper into an example here in a little bit, but we need to use edit in place, which opens up our modeling tools. We are saving an associative reference to anything else in the assembly that we grab. So for example, if I project, let's say, this edge here, and so that's projected into my sketch. That now creates an external assembly context of that body. And so this is the way in which we work with these XREFs, these edit in place things. And so for example, if I activate that, it's going to show that I used that body, that component, in the context of this assembly. Now, where we start to get into problems with this workflow and that you need to be very careful with is if we start to do things like add fillets and chamfers. So for example, if I just fillet this bottom edge, what's going to happen is it's now going to throw a warning or an error that it no longer has its reference for the revolute joint that I added. And that's because the edge I selected to add that joint is gone. It created a fillet which took that edge away, so now it doesn't exist anymore. It's using a cache of that data, so it still works, but there's an error here because that edge is gone now. And so what it needs is an additional reference for this to be able to work. And so that doesn't mean that you can't still do these things, but it means that typically when you work in external reference assemblies, what you should be doing is not relying on modifying that geometry until or not putting it together until the geometry modifications are really done. Or you're going to have to go back and fix some of these references. And then that third approach, that hybrid approach, is really, again, what we do now. We can create multiple bodies, we can convert them to components. The main difference that you're going to see here is that the assembly tools now exist on their own. And so instead of having an assemble dropdown, you just have to go to the assembly menu. And part of the reason for that is the way that Fusion has done this is actually to just hide certain things from us. All these designs, whether it's a part, an assembly, or a hybrid assembly, they're all F3D files if we save them as archive files externally. And so the file type is the same, the geometry is the same. We're just getting restricted access to certain tools. But again, there is this metadata associated with those types. And so now that we've seen that, let's take a look at building an assembly, and let's talk a little bit about how we can deal with multi-body parts and converting things back around. So if we're going to build an assembly, let's go ahead and start a new assembly design. The first thing we're going to do is pick external components. Typically, this would be the base or some sort of fixed portion of your design. In this case, I've got a locator. The next thing that we would do is just begin adding those additional components. So I'm going to add an angled bracket, maybe put it over here, and then I will add the roller for this design. And I'm just going to rotate it and stick it maybe over there. All right, and so now when we put these together, we need to use either joints or constraints typically. Now, the way that we need to think about difference between the assembly methods is a joint is a way that we can drive the degrees of freedom, or essentially lock all the degrees of freedom that we want based on a single selection. This is typically going to be a point, a joint origin. The constraints are where we're taking away degrees of freedom one set at a time. And so, for example, if we were to put this bracket onto this locator, we start by aligning the cylindrical, the boss here with this hole. And then the part can still move up and down, it can still rotate, and then we need to put it down into place and lock it with other references, like stopping at that bottom face and up against this edge here. And so the way that we go about that in Fusion is the same. We pick our references, we add them, so in this case, the bottom face to here. And then to lock it completely down, we'll add the side face and we'll lock it either to this edge or that face there. And then we'll say okay. And so now those two are completely constrained. It's locked in place. So if I went back to the locator and let's say edit the original position and kind of rotate it around, the bracket's going to move with it. And that's just kind of the nature of it. Now with joints, again, what we're doing is we're taking a single location, in this case, a joint origin, even though we're not creating one, and we're dictating the degrees of freedom based on that location. And so in this case, revolute makes the most amount of sense. But if we said cylindrical, the This lets it rotate and move in and out until there's like a bolt in place. And so when we think about this method of attachment, this essentially what we're doing is we are saying we know this is how these two components move. We're going to just restrict the degrees of freedom to only allowing this to rotate. Now, in reality, what you would have is the back face of this is going to be touching the front face of this in some instances, right? In this case, there's actually a gap, but that's going to be a driving feature. And then this concentric relationship between the centers is going to drive the part rotating about it. And so you can get to the same result in both cases. It's just going to kind of determine the types of things you're putting together. Now, within this, again, we've got those edit in place assembly contexts. So if we're creating, let's say, a sketch here, and we want to project a reference from the backside of the pulley or the roller, then what we're doing is we're creating that context, in this case, context 2, and that can be used outside of this assembly. And so if we have, an angled bracket open, for example, and we've got an external context, we can activate those and we can continue to model and use those as references if needed. And so the benefit here is really when you're working collaboratively with a team, you don't need to restrict or reserve an entire assembly or file that's a hybrid file and kind of lock it down so nobody else can work on it. You can grab the references you need. In this case, the only thing that matters for us is this base piece, this locator, and we can continue to work with that file independently of the others. Now, if they happen to go out of date, so for example, let's say that I make a change here and I save this, what this is going to do is it's going to go everywhere there's a potential problem. Any assembly I've created that has these pieces in it, maybe it's right here, any assembly that has these pieces in it is going to, what's this one right here? It's going to say, hey, it's out of date. We need to make a change. We need to update everything that we've done. And so there will be this sort of trickle down effect as these parts get modified. But what it means is I didn't need to reserve the roller or this base piece. I can work with them. And I can work in the context of an assembly, but it can also be independent of each other, independent in terms of who's working on it. And now the hybrid approach, again, is just the way that we use Fusion now. So it's not really a good use case for us to go through it. But what I do want to talk about is going to be how we convert from these design types. So let's say that we create a multi-body part, for example. So I'm going to create a sketch, create a circle, and I'll just use this. Again, this is a quick example. I could just use primitives, but I get kind of used to doing things. And so this file is going to have multiple solid bodies. And so if I had meant for this to be a hybrid, there's really two options for me. One is to insert this to an assembly and then convert the assembly to hybrid. And really the most realistic one is to change this from a part design into a hybrid assembly and convert it. And so what this will do is it'll open up our assembly tools, and then we can just continue to work with it as we would. So for example, let's convert these to components. And so now they can move about, they have their own coordinate system, and we can just treat it like a traditional Fusion assembly by converting it to a hybrid design. And now another way that we can work, I'm going to go ahead and close out some of these. Another way that we can work is by going to Utilities and toggling on modeling tools, breaking links to external references, and then converting those bodies to components. And so that is certainly one other method that we can do. And then remember that each of these is going to have their own sort of metadata associated with it in document settings. So this assembly design, let's say we wanted to convert it to hybrid. What this is going to do is it's going to enable those tools. You notice that the checkbox goes away, but it's going to enable those tools, turn it into a hybrid assembly, and then we could just work on it in that context. Now, as I said, this is a tricky subject. It's something that definitely needs a lot of time. We will be creating some more detailed, in-depth content, walking through some examples of this, but I thought it was important to at least talk about the topic, explain what this new experience is, and then make sure that everybody has the ability to toggle it on and play with it. Now, if you have any questions on this, let me know as we work on updating our content on our website and getting a new assembly module ready to talk about this stuff. If you have any questions, feel free to comment here. And as always, thanks for watching, and we'll see you in the next one.